is about using the Suvat equations, especially part B of this question, and we'll go through why. But in this type of question, drawing a diagram definitely helps. So it says a particle is projected vertically upwards from a point 1.5 meters above the ground. So let's say this is ground level. It's already 1.5 meters above the ground, and it's projected upwards from that point there. So what will happen in its motion, I'll just show you in a different color, is, well, it's going vertically upwards and then it's going all the way back down. It tells you that the initial speed that it's set off with is 10 meters per second, and it's asking you to find the greatest height reached by the particle for part A of the question. Now, what we know about the greatest height vertically is that velocity is 0, and we're going to use that. Oops, why is the highlighter up? Yeah, we're going to use the fact that velocity is 0 at max height. That does only apply to the vertical velocity, by the way, that's 0. That's because it has to stop for a small period of time while it changes direction, and in going downwards the velocity would be negative, because velocity is a vector, so it can be positive or negative. Now in part A, we have enough variables to use Suvat because we're trying to find up to where the final velocity is 0. That will give you the greatest height. It tells you that the initial velocity that it's set off with is actually 10 meters per second, and it's asking for the greatest height. We're going to focus on finding the displacement that it goes to reach the maximum height. After we find that displacement, we're then going to add it on to the height that it initially is above the ground, 1.5, and that'll give you the greatest height reached. What else have we got? Do we have the time that it takes to get maximum height? No, but we do have acceleration, because if something is going in the direction of gravity, we assume the acceleration is g, or 9.8. But if something is going against the direction of gravity, then we assume that the acceleration is minus 9.8, because it's opposing gravity. So our value of a here is going to be minus 9.8. Let's rub this diagram out just so we have more space. So I'm just going to change the pen color. I might as well just change it to black. Now the equation linking S, U, V, and A, sorry, I didn't get the equations on this whiteboard, but the equation linking these variables is V squared equals U squared plus 2AS. V in this equation is 0, so 0 squared is 0, is equal to U squared, which is 10 squared, which is 100, plus 2 multiplied by A, which is minus 9.8, multiplied by the displacement that we're trying to find. Simplifying this term on the right, 2 times minus 9.8 is minus 19.6, S is equal to 0. Add 19.6S to both sides, so we get 19.6S is equal to 100. Divide both sides by 100 and we get S equals 5.1 meters. If it's displaced 5.1 meters extra, so this isn't an accurate drawing, but if it's displaced an extra 5.1 meters from where it starts, the total height above the ground reached by the particle is 6.6 meters. So that's the answer to part A. 5.1 plus 1.5 equals 6.6 meters. Your final mark, by the way, is for adding 1.5 onto the displacement that you find. Okay, hopefully that made sense. Let's now move on to part B of the question, which is a bit more difficult actually. So it's asking the time for which the particle is more than 3 meters above the ground. What could that mean? Well, technically talking, since it's 1.5 meters above the ground already, in order for it to be 3 meters above the ground, it needs to be an extra 1.5 meters above where it currently is. So like here, that would be 3 meters above the ground. And if you think about it, if we draw a line here, it's going up from that point all the way back down. If we find the 2 times at which the displacement is 1.5, because that would mean that the height above the ground is 3 meters. If we find the 2 points at which the displacement is 1.5 meters, that will give you and you find the time in between those two times. So let's say this time is 1 second, this is 4 seconds, 4 take away 1 is 3. The time in between is where it's more than 3 meters above the ground. So just to repeat myself, we're going to find the two times at which the displacement is 1.5 meters, and then the time in between those two times is when it's more than 3 meters above the ground, because that's what's visible on the diagram. So let's focus on doing that. S is 1.5, U is the velocity that it starts off with, which is 10. Do we know the velocity when it's 1.5 meters above the ground? No, it hasn't given us it to us. We know the acceleration is initially upwards, so it's against gravity. That's actually a very important point. The acceleration that you take is always the one at the beginning of the motion that you take. So because it's starting going up, we take it as minus 9.8, even though it goes down later. And we're trying to find t. The equation linking SU, A, and t is S equals ut plus half at squared. So S equals u times t plus a half times a times t squared. A half of minus 9.8 is just minus 4.9, so let's replace that. From here, you make it more so like a quadratic by taking the t squared to the other side and the 10t, and then we end up at this quadratic here for us to solve. And what you do get actually is that t is equal to 1.2 and 4.2 seconds. And then the time in between these two times is where it's more than 3 meters above the ground. So 4.2 take away 1.2 equals 3 seconds. Hopefully that made sense. And if you have any questions, please let me know in the comments. It's quite a difficult concept to understand. Hopefully you can see how drawing it out helps. It did say 3 meters above the ground, so it has to be displaced 1.5 meters from where it originally is in order for it to be 3 meters above the ground. Yeah, thanks for watching.